Okay, now we sketch the graph of modulus function. Okay, here please take note. When you sketch the graph of y equals modulus of x, the part lying below the x-axis means fx is negative. When you take absolute value, we'll make these values positive. Okay, so whatever below the x-axis, the y initially negative. When you take the modulus of y, it becomes positive. So we're going to reflect in the x-axis any part of fx lying below. So for the first one, it's a quadratic. And if I factorize, I can see there are two roots. X equals 0 and x equals 3. Yeah, so this is fx. Now, if I want to sketch the modulus of fx, remember the part below the x-axis for this part, when you take the absolute value, it will become positive. So they will reflect above x-axis. And for those part that is above x-axis, remain. Okay, so this is x. Okay, this is fx. So the part of the curve that is below the x-axis means f less than 0. So when I reflect up means absolute value of f is more than 0. Okay, now how about f absolute value of x? Okay, for this one, right? Because whenever x is negative, after you take absolute value, it will become positive. Of y equals fx to the left of the y-axis. Okay, to the left of the y-axis. That means the part where x used to be less than 0, this part are completely removed. And then replaced by the reflection of the parts of fx to the right. That is because initially, imagine initially your fx can take the value from -2, -1, 0, 1, 2. Okay, for example, maybe your fx is 8, 7, 6, 5, 4. Okay, but after you take in absolute value, okay, so all these negative will become positive. And then when you sub this into fx, that should give you same value as f2, f1, f0, f1, f2. So the value now become 4, because f2 is 4, 5, 6, 5, 4. So whatever on the right will be reflected to the left. And then what used to be the value of fx, because the value of x substituted into it is a negative number, is taken away. Okay, they are no longer there. So back to this one, the part of fx to the left of the y-axis is completely removed. Completely removed. What is used to be the fx? This one, right? So the one on the left completely removed. Okay, and then the one on the right reflect. So this one x-axis x-intercept is 3, now become -3. So this is f absolute value of x. And then you can use the calculator to check. Okay, if you are doing homework, you can also use the decimal graphing calculator to check. Okay, now let's look at next one now. For this one, because of not enough space, so after I draw the graph, I will erase later. So when you watch this video, you can pause the video and then taking down the graph. Okay, this is sin x. If I take absolute value of sin x, whatever below become above. Okay, so that will be fx. Okay, that is fx. Next one, y equals sine modulus of x. Okay, so for this one, I need to see it originally, what is my fx? Okay, originally, my fx is, right? So now, remember, part of fx to the left of the y-axis, to the left of the y-axis, totally removed. And then replaced by the reflection of the parts of the fx to the right of the axis. So this part reflects. So this is absolute value x, sine absolute value x. Okay, so you can pause the video and then taking out the graph. But now I need to move on. E to x. You notice that to do this chapter, you must be very familiar with the function. For each type function, you must know how the graph looks like. This is e to x. Now, e to x is same as absolute value of e to x, because the whole function lies above x-axis. So y equals e to x, and y equals absolute value of e to x makes no difference. Now, when it comes to y equals e to modulus of x, so the one on the left, remove. Right, so the one on the left, remove. And then the one on the right, reflect. So this is y equals e to absolute value of x. It's not the curve you must know. Obviously, here it is a bit sharp. Okay, here it's a bit sharp. It's not really a quadratic curve. Okay, next one. Next one is a cubic function. You got 3 roots. And because the coefficient of x cubed is equal to 1, positive. Okay, because x times x times x is x cubed. The coefficient of x cubed is 1, positive. So the curve should go this way. 3 roots minus 2, 0, and 2. This is fx. So if I change to fx absolute value, what is below? Reflect above. What is above? Remain the same. So this is the red one is modulus of fx. For this one, that means it is right. So I need to once again take away the part on the right, on the left of the y-axis. Okay, this is y-axis causes at s equals 0. So whatever on the left is gone. Okay, this is on the right, so reflect. Okay. Okay, so this is f, absolute value of x. Okay, part B, y equals 1 over x. No xy intersect. So y equals absolute value of 1 over x. The part below go above. This one go above. Okay, so that is this. The interesting thing of this one is for f absolute value of x, that means y equals 1 over absolute value of x. So what will happen then is, okay, initially for x. To get f absolute value of x, take away the one on the left of the y-axis, reflect the one on the right to the left. Then you realize this is same as fx, the whole thing modulus. Okay, so this is how we draw the modulus function of fx and f bracket modulus of x.